Flack math! Give me some math and I'll give you some flack. Flack math! Okay. A banner is shaped like a parallelogram with a diagonal of 4 feet. As shown, calculate the dimension, the values of x and y to the nearest hundredth. Okay, so I'm going to zoom in just a little bit so I can see that. All right, so we've got parallelograms, which means we have parallel sides, correct? So that means we also have the properties of parallelograms say that the opposite sides are congruent. But really what we're looking at here, it looks like there's a right triangle. And then we've got y's here on the angle. So right triangle, we could use our Pythagorean theorem to figure out what x and what x is. So let's see here. So a squared plus b squared equals c squared. Let's start with that. So it looks like a is x squared, b is 4 squared, or not, b is 4, so b squared is 4 squared. And then we've got 2x squared. So put a parenthesis around there. If you don't, you're just squaring the x, okay? So let's simplify that. So that's x squared plus 16 equals 4x squared. So get the x squareds over here. And you get, let's see here. Am I reading this right? I just want to make sure I'm reading it right. Okay, so get the x squareds over here and you get 16 equals 3x squared. Divide by 3 and you get x equals the square root of 16 divided by 3. Because if you divide by 3, x squared equals 16 over 3. And then take the square root of that and you get square root of 16 over 3. Now you can take the square root of 16, so you could write it like this: 4 over the square root of 3. Okay, but it doesn't really matter because you're going to calculate it to the nearest hundredth anyway, right? So let's just divide 16 by 3. 16 divided by 3. And then what we're going to do is I'm going to expand this a little bit. How do I do that? Do I just do that? Nothing, really. Large, type, no. Shoot, come on. There it is. Okay, so we got this, and now we're just going to square root it. So 2.309, it says round to the nearest hundredth, so 2.31-ish. So x equals 2.31-ish, or approximately 2.31-ish. Is that what you guys got for x? Something like that? Ish, okay. All right, now y's, so this y isn't too bad because basically we know that that all the angles have to add up to 180, but if one of them is a right angle, then these two acute angles, and this is actually a property that we learned, have to add up to 90, because 90 plus 90 is 180. So I'm just going to rewrite these equations. 4y minus 6 plus 6y plus 6, that has to equal 90. Okay, because these two acute angles in a right triangle have to equal 90 because they all have to equal 180. All right, so let's just simplify and solve this equation. 4y and 6y is 10y, and then the 6's cancel. Minus 6 plus 6 cancels. So 10y equals 90, so y equals 9. Does that make sense? All right, so if you have a question, you can raise your hand and raise it high so I can see it. And then I might have to have you come up with your mask and ask your question on your mass or on the video, okay? Because it's hard to understand when you're sitting far away. All right, number 2. What is the measure of arc CD? Well, that's a central angle. So this is a nice one. Measure of arc CD is just the same as that central angle, which is 25 degrees. Okay. It doesn't say arc length. Arc length is different. And the arc length, you need to figure out what the circumference of the circle is and just take that fraction of it. It just says arc measure. Measure is just the degree. Okay. So that's fine. Let me just, and every once in a while, I'm going to just check our test to make sure there's nothing too crazy. It's not too different than what we're doing, okay? So you guys should be fine there. All right. Any questions with number 2? All right, number 3. Use ASA congruence theorem, so angle side angle, to determine the measures of the sides of triangle XYZ. Okay, so if these guys are congruent, then their corresponding parts are congruent. Okay, so YZ has to be congruent to the corresponding part of YZ, which is BC. So BC is 3, so measure of YZ equals 3. Measures of the sides. Okay, so let's see. Measure of, what is it? XY. So that's the other side of the obtuse angle there. So that's AB, which is 8. And then the measure of the last one, XZ, equals AC, which is 10. Is that good? You guys handle that? All right, good. Number 4, find the area of the parallelogram with the height of 5y and the base of 4x. Well, to find the area of a parallelogram, it's just base times height. So write that down if you don't know it already. Base times height, so the base is just 4x. The height is 5y. What's 4x times 5y? 20xy, okay? So there's no units, so you could just say square units or SQ units is fine. But that's it. Oops, I don't want to do that. That's messy. Okay, any questions with that? A little bit of algebra in there. Number 5, determine the midpoint of the line segment with endpoints 3, 6, and 4, 10. So you could use the midpoint formula, which is just the average of the x's and the average of the y's. So the average of the x's, just add them together, divide by 2, 3 plus 4. Divided by 2, and the average of the y's is 6 plus 10 divided by 2. So this is what, 3.5, comma 8. Is that what you guys got? If you were to graph these, you could probably see on the graph where the midpoint is. So if you want to do that just to be safe, you can do that. But it's just halfway between the x's, halfway between the y's. Halfway between 3 and 4 is 3.5. Halfway between 6 and 10 is 8. All right, number 6. So this is a proof, and we're asked to prove this theorem. So if 2 lines are perpendicular, then they form congruent adjacent angles. Okay. So we're going to prove that angle 1 is congruent to angle 2. Okay, so we don't have to prove anything else, just that they're congruent. So if the lines are perpendicular, they form these 2 things. Okay, so let's try this. And again, let me just look at the actual test here to make sure there's nothing too weird. Okay, the other one is similar to this, but it's a little bit different. So I'm going to tell you the theorem that you're going to be asked to prove on the test. Okay, so if you need to refer to this video a little bit later so you can study. But if two angles, so think about this as we're doing the practice test. If two angles form a linear pair, then they are supplementary. Okay, so linear pair means that they like a straight line and there's an angle. So we're just going to prove that that those two are supplementary, or they add up to 180. Okay, but on this one, the practice test, if two lines are perpendicular, then they form congruent adjacent angles. So first statement is given. So whatever the given is, let's see here. AB is perpendicular to CD. And then I'm going to say angle 1 and angle 2 form a linear pair. So that's what's all given. Okay. So this is very much like the other test. Angle 1 and angle 2 are a linear pair. Lin pair. Why? Because it's given. So there's 2 easy points on this proof already. Okay. So far, so good?
Yeah.
All right. Let me just check on the real test. Okay, so AB is perpendicular. Well, what does that tell us? Well, it says then they form right angles, right? Perpendicular lines form right angles. So we're going to say number 2, angle 1 is measure of angle 1 equals 90, and measure of angle 2 equals 90. Why do you know that? Because that's what perpendicular lines do. So whenever you find yourself answering the question like that, well, that's just what perpendicular lines do. Then that's the definition, perpendicular lines. So def, perpendicular symbol, lines. So step 2 complete. All right, so now what are we trying to prove? That they're congruent. Oh, okay. So if measure of angle 1 equals 90 and measure of angle 2 equals 90, how can we say that angle 1 is congruent to angle 2? Why can we say that? Anybody know? There's 2 possible answers. If they both equal the same thing, we can use there's 2 possible reasons for that. Either the substitution property, because all we're doing is substituting angle 1 in for 90. And so measure of angle 2 equals 90. Measure of angle 2 also equals measure of angle 1. Or the transitive property. Remember, it's like the journey. Measure of angle 1 equals 90, and 90 equals measure of angle 2. Then that means the first thing equals the last thing. Measure of angle 1 equals measure of angle 2. So that's the trans prop or the sub prop. Okay. So keep in mind these steps, what we just did. So when you do your proof on the test, you'll have similar types of things. Okay. All right. Number 7, find the arc length. So now we're finding the length, not the measure. We're finding the length. So I'm going to draw a little circle here. Okay. And then we're going to label it here. Let's see here, the radius of 24 feet. So that's 24 feet. And then a measure, an arc measure of 120. So let's see, 120 looks maybe like that. Okay. So this is 120 degrees. But we want to find this length. Okay. Well, we know how to find the circumference of a circle. But we don't want the whole circle. We want a fraction of the circle. We don't want the whole 360-degree circle. We just want 120 out of the 360 degrees. So that's a fraction. So the measure of the arc equals this fraction, 120 over 360, which you can reduce that to a nice 1/3, times the circumference of the circle. Remember, circumference is just pi d, pi times diameter. Okay, so I'm going to rewrite it. Measure equals 1/3 pi times 48, right? Because if the radius is 24, the diameter is 48. So I'm going to multiply the 1/3 and 48. So that's 16. So the measure equals 16 pi. If you want to multiply that out, you can. I think it's 50.24. And to get a rough 50.24. But let's see, what does it ask for? Give the answer in terms of pi. All right, so there it is. 16 pi, let's see, feet, and you're done. Okay, so that's how you do it. But let me just give you the shortcut. Throw this 120 over 360, reduce it if you want, multiply that by the diameter and pi, right? Because you're just finding 1/23/60th or 1/3 of the circumference, not the whole circumference. Okay. You guys good with number 7? You guys think you can handle it? No questions? Okay. Number 8. For triangle ABC, determine the measure of ACD. All right. Well, there is a little property. It's called the remote angle, exterior angle theorem or whatever, that says that the measure of this exterior angle, which is the one we're trying to find, is equal to the sum of its remote, of the triangle's remote interior angles. If you remember that, great. But by your powers of deduction, you could probably figure this out anyway without that theorem, because all the angles have to add up to 180, right? So if you find this angle and then you find the supplement, well, when you find the supplement, you're really just finding the sum of those two angles. So this equals 45 plus 85. So that's 130 degrees. Now, if you did it the long way, well, if this is 130, then that means this has to be 50. And these are supplementary angles. So let's see, 180 minus 50 is 130. Oh, where have I heard that number before? Oh, it's when I added those two remote angles up. Okay. So if you remember the shortcut, great. If not, do it. Just figure out that third angle and subtract it from 180. You just wasted a little bit of your life, but I'm not going to judge you. You're fine. Okay. Number 9. Determine the contrapositive. Ooh. Nice. If of the statement below. Okay, so if Lily has a dancing lesson, then it is a Saturday. So the contrapositive, remember what you do there? You negate both things and you reverse them. So it's like the negated converse. All right, so the contrapositive says if it is not Saturday, then Lily does not have has no dancing lesson, does not have a dancing lesson. Then Lily does not have a lesson. Okay, so you reverse it and you negate it. You guys think you can handle a contrapositive? Okay, let me look on the test. It's asking for a contrapositive on the test too. So I think you guys will be fine. You guys good? Any questions? All right, number 10. Use the given flowchart to write a 2-column proof. So basically, we're just repeating the information we see on this flowchart. So I'm going to zoom in just a little bit here. And then I'm going to rewrite it here. So you might, I think I can fit it in there, but we'll see here. I'm going to go a little bit smaller stroke. So given the first things are still the same, angle 1 and angle 2 are complementary. Also, angle 2 and angle 3 are complementary. Why do you know that? Because that's what's given. So statement 1, reason 1. Reason 1 is given. Okay. So statement 2, well, we don't have to figure out this proof because it tells us. So both of these are the same thing. So we can put these all on one line and say measure of angle 1 plus measure of angle 2 equal 90. But so do measure of angle 2 and measure of angle 3. Why do you know that? Well, it says it right underneath there, definition of complementary angles. So def comp angles. All right, number 3, statement 3. Let's see here. What did they say? I think we could probably figure it out, but all we're doing here is, let's see, measuring. So you're just subtracting. So it's just subtracting. Well, they do kind of a weird thing, but we're okay. We can just copy it down. So I'm just going to write down those statements. Measure of angle 1 plus measure of angle 2 minus measure of angle 2 equals 90 minus measure of angle 2. All we did was subtract the same thing from both sides. What property is that? That's the subtraction property of equality. Okay. So remember, if you label it, if you abbreviate it, make sure you put a TR, not just a sub, because we don't want to confuse that with substitution. And that's the same thing with measure of angle 2 and angle 3, right? So you're just subtracting 2 from both of those. Measure of angle 2 plus measure of angle 3, or minus measure of angle 2, also equals that same thing, 90 minus measure of angle 2. So if two things equal the same thing, we could use our nice little, if they both equal 90 minus measure of angle 2, then we can skip right down here, or we could put those if you want, simplify. Remember, we don't need the simplify step. So we're going to skip down to measure of angle 1 equals measure of angle 2, because they both equal the same thing, or measure of angle 3. They both equal the same thing. So what property is that? I don't know if you're saying anything, but remember you have two choices. Do you know, Tristan? Are you raising your hand? Okay. I can't hear anything, but so it's either the transitive or substitution, right? So it doesn't matter which one you pick, but let's do whatever they did. They use substitution. So subst prop. Okay. And then they did one more thing just because that we're technically asked to prove that they're congruent. So angle 1 is congruent to angle 3. We can't just say the measures are equal, even though that's what congruent means. And if that's what congruent means, then our reason for that is definition of congruency. Okay. All right. So on the test, you're going to have something very similar to that. You'll have a flow chart. All you have to do is write down those statements, the same thing, and you can write it just like this, double up each statement with the both columns of that flow chart. And then the reasons are right under it. So you just have to reorganize the flow chart. And you don't have to include the simplify step, but if you do, that's fine. Okay, next page. All right, number 11. Question? No question? Okay. Number 11, the area of a rectangular photograph is 120 square inches. The photograph's length is 2x plus 2. Okay, that's a little bit of algebra, but we can do this. Fret not, Tori, don't be scared. So if the area is 120 and the length is 2x plus 2, and the width is 3x, how do you find the area of a rectangle? Length times width. Okay, so we're just going to multiply these two guys together. So we get 2x plus 2 sorry. 2x plus 2 times 3x. So that's what our area is. But we already know our area is 120. So 120 equals, distribute that, 6x squared plus 6x. Okay. All right. And then find the dimensions of the, so we're going to provide a justification for each step. So the justifications are definitely going to be extra credit. Okay. So as you're doing this algebra, you can do the extra credit if you want. But so basically, when you say area, first thing, area equals length times width. That is definition of the area of a parallelogram, or you can just say, or area of a rectangle. So you can say area of rectangle. So that's step 1. Step 2, area equals 3x times 2x plus 2, or 120 equals 3x. All you're doing is substituting in your variance. So what's the reason for that? Substitution. Subst-prop. Number 3, you're just simplifying that. So 120 equals 6x squared plus 6x. Simplify. Okay, and then we got step 4 is we're going to solve this quadratic. Let's see here. Find the dimensions of the photograph. So we have to solve for x first. Now this is where it gets tricky, guys. You have to find the x that works. So to solve a quadratic equation, that goes back to some algebra. And there's different ways to do that, but you can divide, if you divide each side by 6, then you get 20 equals x squared plus x. And then if I get, so if I rewrite it like this, I'm going to just do this. X squared minus or plus x minus 20 equals 0. Solving for x, that's when you do the factoring it out. So we get x plus 5, x minus 4. And so it can't be x equals -5, so x has to equal 4. And the reason we did all this was the reason for that was factor. And then to solve for this x minus 4, we just did the addition postulate. So this, instead of making, I'm just going to make this whole thing extra credit. So I'm going to give you double extra credit if you give me justification of each step. But if you just find x and give me the dimensions of the rectangle, then I'll give you extra credit for just doing that. So if x equals 4, then we're going to plug 4 back into these dimensions. So then this has to be 12, and this has to be 8 plus 2, which is 10. So it's a 10 by 12 rectangle. So this is a tough one. So don't spend too much time. If you're stressed about this and you don't understand it, I am going to make this extra credit. Some of you came directly from Algebra 1. So this is especially difficult. We did go over this at the end of the year, but we didn't spend a lot of time on factoring and solving for quadratic equations. Okay. So if you want to attempt this, you can and get some extra credit for that. That's fine. All right, number 14 is determine whether the pair of angles is congruent by the SAS postulate. Well, SAS means that the two sides are congruent and the included angle, or the angle in between the two sides, are congruent. Okay, so that doesn't tell us that. Just because this side is congruent to this side and this side is congruent to that side, it doesn't say that the angle, see, the angle is not included. Okay, so this doesn't work. So you just say no. All right. So see how the angle in between those two congruent sides has to be congruent to the angle in between the two congruent sides on the other triangle. Okay. So if it's not, then the answer is no. If it is, the answer is yes. Okay. And it may not be the SAS postulate. It could be ASA or AAS. Okay. Or SSS. But those are the only options. All right. So I think you can use your gut to be able to tell, but it's kind of obvious that these triangles are not congruent, but look at the markings. All right, number 13, consider the following conjecture. If the product of two numbers is positive, then both numbers are positive. What is the hypothesis of the conjecture? So the hypothesis is the if part, right? So just ignore the word if and then write what comes after the word if. The product, I'm just going to circle it here so I don't have to rewrite it. The product of two numbers is positive. Okay. What is the conclusion? Well, that's what comes after the word then. So then, and then after the word then is both numbers are positive. Okay. Find a counterexample for the conjecture. All right. So if product of two numbers is positive, both numbers are positive. What's a good counterexample? Well, negative times a negative equals a positive. So you can just pick any two numbers, any two negatives, multiply and get a positive number. Okay. On the real test, let's see here. The real test, yeah, it's a little different, but same kind of thing. So you just have to prove this wrong with just one example. That's what a counterexample is. Okay. You guys think you can handle that? Identify the hypotheses and conclusion, and then give a counterexample if it's not true. All right, look at number 14. Oops, I put that on the wrong line again. Sorry. Number 14, in triangle RST, SC equals 15, find CX. All right, so look at this guy. We're going to zoom in a little bit here. Keep going. You can do it. All right. So RST. So SC, this guy right here is 15. Find CX. Do you guys remember the little formula? So really, SC, sorry, I did that wrong. So the whole thing is 15. So CX is 1/3 of that diagonal or that median, okay? So if SC is 15, 1/3 of 15 is 5. It's hard to see. So SC, or what is it? CX equals 5. Okay. If it was asking for SX, then SX is 2/3 of the whole thing. So you can, again, use your gut. You can tell that, okay, CX is 1/3 and SX is 2/3. So it depends on what you're given. All right, let me make sure there's nothing weird on the test. Yeah, you'll be fine. Okay, so it's 1/3 and 2/3 is the ratio. Can you guys handle that? All right. Okay, number 15, determine whether polygon ABCD is convex or concave. Concave, remember, it caves in a little bit. Convex is the normal type of polygon that we're looking at. So here's the cave. It caves in. The other way to tell is if you're going around the object and you have to switch directions. So if you walk around this building and with your hand on the wall, You walk around, and then when you get to B, you have to turn right instead of left. And you turn left so if you're going from D to C, and then C to B, and then B to A, when you get to B, you have to switch directions. The other way to think, if you can draw a diagonal outside of the object, like from A to C, then that's a concave polygon, okay? But again, use your gut. That polygon just got punched in the face. Poor dude, whatever. Probably deserved it. Okay, number 16. Find the unknown length in the triangle below. Okay, so do the, let's use the Pythagorean theorem to figure that out. We can do that. So whenever you do a Pythagorean theorem problem, just write it out. Pythagorean theorem is a squared plus b squared equals c squared. Now let's plug in, let's replace the a, b, and c with what we can. It looks like the x is the hypotenuse. So we're going to leave that x squared over here. We're going to plug in 18 squared and 24 squared. So far, so good. Okay, so if you do this math, what's 18 squared and whatever, blah, blah, then you get, let's see here. Add those together. Let's just do it. Let's just do it. Let's just do it. Let's just do it. 18 times 18, 324. And then 24 times 24, 324, 576. 324, 576. Whoa. So 324 plus 576 equals x squared. So x squared equals 900. Square root both sides, x equals 30. So is this a Pythagorean triple? Yes, it is, because they're all whole numbers. So we say 30, and then we say yes. Now, I could have told you that this was a Pythagorean triple because look, if I divide both of these sides by 3 or by 6, I get 3 and 4. So this is the equivalent of a 3, 4, 5 triangle. Okay, so you can figure that out without even having to do the Pythagorean theorem. So if you divide by 6, then you get 3, 4. And so this has to be 5. So what divided by 6 is 5? 30. Okay, so you can figure it out that way, but use the Pythagorean theorem if you're at all confused about that way. Okay, can you guys handle this? Yeah. So remember, if you get a nice number without a decimal, then it's a Pythagorean triple. Did I hear a question? Anybody have a question? Okay, I can't hear you. So if you have a question, come put your face with the mask in the camera. All right, number 17. Determine the area. Can't believe this question made it on here. How nice. Area of a triangle is 1/2 base times height, right? Or base times height divided by 2. So we got 1/2 times 3 times 3. So that's 4.5, right? Because 1/2 of 9 is 4.5. Centimeters squared. Any questions with number 17? All right, number 18, find the area of a circle with radius of 7. You can draw it if you want to. Radius of 7. Use 3.14 for pi. Okay, so area equals pi r squared. Make sure you know that. So we're going to use 3.14 for pi, and this has to be equivalent, not equal to, times 49, right? See how I got 49? Good. All right, let's do that. I'm going to do that on my calculator here. 3.14 times 49 153.86. So this is approximately 153.86. That is not 0.86, okay? And then what is it? Inches, so square inches. Questions on that? Just plug it into the formula and go for it, okay? Two more. Following statements use the law of detachment to write a valid conclusion of the statement. So if an integer ends in 2, then it is an even number. The number 32 ends in 2. Guess what? Therefore, you can just write the symbol for therefore, which is the 3 dots here, right? Therefore, 32 is an even number. So law of detachment is just like an if-then statement. Okay. Syllogism, remember, is when you have if this is true and this is true, then this is true. So detachment is just one if and one then. Okay. Can you guys handle that? Number 19. All right, number 20, find the value of x in the triangle below, write your answer in simplified radical form. Okay, same thing with Pythagorean theorem. So first step, write it out. X squared or a squared plus b squared equals c squared. So this time we're given a and b. We're trying to find x. So 10 squared plus 10 squared equals x squared. So 100 plus 100 is 200 equals x squared. Oops. All right, so square root both sides. So x equals the square root of 200. Now I want to do simplified radical form. So we talked about this briefly, but you're looking for the biggest square inside of 200. So you're looking for a factor that is a square that you can pull out of there. So the square of the biggest square I know of is 100. So the square root of 200 is the square root of 100 times the square root of 2. Well, what's the square root of 100? Is 10 times the square root of 2. So this is your final answer. All right. So this is what I want you to have your simplified radical in. Now there's a shortcut to this. And I don't know, you might, most of the time, right, the test is just like the practice test. So pay attention to this shortcut. What's the difference between the answer and the length of one of these sides? Well, you just put a radical 2 on there. That's a shortcut because this is an isosceles right triangle. Whenever you have an isosceles right triangle, the hypotenuse is always the length of a side times radical 2. This is a shortcut. This is a nice tool that you can use when you're trying to determine the hypotenuse of an isosceles right triangle. So if these two sides are the same, you just tag on a radical 2 to your answer and you're done. That's a nice trick. And keep in mind that the real test is almost always identical. We just changed the numbers. Okay, so if this length was elephant and elephant, then your answer would be elephant radical 2. Okay, so remember that shortcut. That's a golden shortcut right there. All right, guys. So here's what I'm going to do. Okay, since we're new on proofs, I'm going to be very gracious on that proof. What was it? Number 6. Number 6, I'm going to be very gracious on that proof. You can do number 10. All you have to do is just translate this into column form. But I'm going to be really gracious on number 6. I'm going to give you credit for what you're able to do. And then I'm going to have a lot of grace for what you're not able to do because we're just learning these. And then remember, number 11 is completely extra credit. So if that's overwhelming you, then don't do it. Okay. All right. Any questions before I sign off?
No.
All right. And okay, I'm not hearing anything. So if you guys still have questions, you can Schoology me, message me, or you can, yeah, that's what you can do. Don't call me. I don't, that's creepy. Okay. You guys good? Thumbs up. All right. Double thumbs up from Tristan. Whoa. Whoa. That's awesome. All right. Good job, guys. Yeah, message me if you have any more issues, but if not, then I'll see you soon.
Black man, give me some math and I'll give you some flack. Black man.